Welcome back, everybody. So this is notes number 6, and we're doing part 2 of our review of solving quadratic equations. Today we're going to be looking at the quadratic formula, which I'm sure you're all familiar with, and I hope you have memorized. But if you've forgotten it, then now's the time to memorize it again. And then we're also going to extend our quadratic equation solving to other sorts of equations and use the same techniques on other equations that are not quadratic. Okay, so let's start with method number 4, the quadratic formula. And the quadratic formula is not just magic. It's not just some magic formula that fell out of the sky. It is derived from completing the square. So I'm going to show you where the quadratic formula came from. And you don't have to write down this part. You can just listen and watch, and then when we get to the examples, you can start writing again. So let's take the quadratic equation ax squared plus bx plus c equals 0. And imagine that our goal is to solve this equation using completing the square. So we know that when we use completing the square, the first coefficient needs to be a 1, and we don't really know right now if a is a 1 or not, so I'm going to divide the whole equation by a. So that gives us x squared plus b over a times x plus c over a equals 0. Okay, now if you remember, the next step I like to do in using the completing the square process is I like to subtract c over a to get it over to the right side of the equation, and I like to draw a little box which represents the space I'm keeping for writing in the number that completes the square. So we have negative c over a on the right side of the equation now, and then of course whatever we add to the left we're going to add to the right. So now remember, the way we figure out the number to add to complete the square is we take this number right here and we take half of it and square it. So half of that number would be b over 2a, and when we square that we get b squared over 4a squared. So that's the number that completes the square, and we add it to the right side of the equation as well. At this point, what we do on the left is we write it in its factored form, so we would have x plus b over 2a quantity squared. And then what we typically do on the right side is we get a common denominator so that we can add the two fractions together. So I'm going to multiply the numerator and the denominator of the first fraction by 4a so that we have a common denominator. So now we have negative 4ac plus b squared over 4a squared. Now, what if we just rewrite that numerator? Instead of negative 4ac plus b squared, what if we rewrite it in reverse order as b squared minus 4ac? Now, at this point, you might be starting to see something familiar. You're starting to see the parts of the quadratic formula come into place. Okay, remember the next step in completing the square is to square root both sides of the equation. So that would give us x plus b over 2a equals plus or minus the square root of b squared minus 4ac over 4a squared. Now actually 4a squared is a perfect square, so let's just write the square root of the top and the square root of the bottom. So we have x plus b over 2a equals plus or minus the square root of the top, the square root of b squared minus 4ac. And then let's go ahead and take the square root of the bottom. Square root of 4 is 2, square root of a squared is a. So over 2a. And then finally, the last step to get x by itself is to subtract b over 2a from both sides. So we have x equals the opposite of b over 2a plus or minus the square root of b squared minus 4ac over 2a. Now, this is the way I like to write my quadratic formula. I like to have the two parts separate, not as one fraction, but as two fractions, and I have a couple of reasons why I prefer it this way. One is that I find that students make a lot fewer mistakes in simplifying if they keep the two fractions separate. And also there's some geometric meaning in this formula that we'll see when we start looking at parabolas again. But it is still equivalent if you learned it like this: opposite of b plus or minus the square root of b squared minus 4ac all over 2a. If you learned it like that, it's still true. I would just suggest and encourage you to try it this way with the two parts separate and see if it helps you, especially if you tend to make any kind of computation mistakes. Okay, so that's our quadratic formula. So the quadratic formula really has two parts. You start by saying, so here's a quadratic formula. You start by saying if, and you'll want to write this down, if ax squared plus bx plus c equals 0, then x equals the opposite of b over 2a plus or minus the square root of b squared minus 4ac over 2a. You really do need the if part in order to conclude the then part. Okay, let's do a couple of examples. Solve using the quadratic formula. All right, so here we have our equation in the right form already, x squared plus 10x minus 20 equals 0. And in this case, you have an invisible 1 on your x squared term, so the a value is 1, the b value is 10, and the c value is negative 20. So using the quadratic formula, we have x equals opposite of b over 2a would be negative 10 over 2, plus or minus the square root of b squared, 100, minus 4 times a, 1, times c, negative 20, over 2a, so over 2. Now we simplify. So we have x equals 5 plus or minus the square root of 180 over 2. And then 180 has some perfect squares, so when you factor out the perfect squares, you end up with negative 5 plus or minus 6 square root 5 over 2. And then finally, we can reduce the 6 over 2. So we have x equals negative 5 plus or minus 3 square root 5. And if you look back at your notes we took last time, we did the same problem last time when we were completing the square. We just did it a different way, and you'll notice that we have the same answer. Okay, let's do number 2. We're going to use the quadratic formula, and it's not ready for that yet. We need to get all the terms onto the left, and we need it to say equals 0. So 4x squared minus 3x plus 5 equals 0. Now we can use the quadratic formula. A is 4, b is negative 3, and c is 5. So we have x equals opposite of b over 2a would be 3 over 8, plus or minus the square root of b squared, 9, minus 4ac would be minus 4 times 5, over 2a over 8. Okay, so we have x equals 3/8 plus or minus the square root of, I believe that's going to be negative 71 over 8. And all we can do with the square root of negative 71 is write it as I times square root 71. So here we have our answers. Okay, then for the last part of our lesson, we're going to do 3 more examples where we don't have a quadratic equation, but we're going to use quadratic methods to solve the equation. So this one would be a cubic equation. And if you look closely at the left side, x cubed minus 125, that should look familiar because of the day we did factoring. Remember the difference of cubes factoring formula, or the SOAP formula, I refer to it as. So if you have a cubed minus b cubed, it factors into a minus b times a squared plus ab plus b squared. Remember the SOAP part of it is same sign as the original, opposite sign, and then always positive sign. So let's start this problem by factoring x cubed minus 125. So it factors into x minus 5 times x squared plus 5x plus 25. And it's equal to 0. So we can use method number 1 that we went over the other day, which was solve by factoring using the zero product property. So we're going to set each factor equal to 0. X minus 5 equals 0, or x squared plus 5x plus 25 equals 0. So we solve each one, so we get x equals 5. But then the quadratic equation that we have on the right, it's not factorable, so we're going to use the quadratic formula. So we have x equals the opposite of b over 2a would be negative 5 halves, plus or minus the square root of b squared, 25, minus 4ac would be minus 4 times 1 times 25, over 2a, so over 2. So then we simplify, and we have x equals negative 5 halves, plus or minus the square root of negative 75 over 2. And when we simplify the square root of negative 75, that part of it becomes 5i square root 3. So our answers are x equals negative 5 halves plus or minus 5i square root 3 over 2. Oh, and x equals 5. Don't forget about that one. So we have all of those answers. I should really say or. Okay, now let's take a look at another problem that we're going to use quadratic methods to solve. So equation number 4 is not quadratic. It's what we call quartic. When you have the power 4 as your highest degree, it's quartic. Like 4 quarters in a dollar, 4 quarts in a gallon, 4 quarters in a basketball game. That's what that means. So even though it's not quadratic, it looks kind of like a quadratic equation. We have a trinomial on the left side, and we can factor this quartic expression. So of course it may take a little bit of trial and error, but once you figure out the factoring, you'll notice that you get 4x squared minus 1 times 3x squared minus 2. And you can always pause the video when you don't want me to just tell you. If you want to figure it out on your own first, just pause and then resume, and you can see me show you the factors. We can compare. Okay, so now once again, using solve by factoring, we're going to set each factor equal to 0. So we have 4x squared minus 1 equals 0, or 3x squared minus 2 equals 0. And you might notice that each of these equations, because they have x squared in them but not x in them, can be solved by square rooting. So to solve by square rooting, we want to isolate the x squared. So for the first equation, I'm going to add 1 to both sides. 4x squared equals 1. Then divide by 4. X squared equals 1/4. Now I can square root x equals plus or minus the square root of 1/4, which is 1/2. So x equals plus or minus 1/2. There we have two answers. And then the second equation can also be solved by square rooting. So start by adding 2 to both sides, then divide both sides by 3. So we have to get the x squared by itself first, and then we're ready to square root. So we have x equals plus or minus the square root of 2 over the square root of 3. Now remember before we did review how to rationalize a denominator. So we multiply the top and the bottom by square root 3. And that gives us x equals plus or minus square root 6 over 3. So there we have 4 answers altogether for that equation. Hopefully it doesn't come as a surprise that an equation that's quartic would have 4 answers. We already have seen that equations that are quadratic have 2 answers, and we saw in problem number 3 that an equation that was cubic had 3 answers. Okay, let's finish with problem number 5. This one we can also use quadratic methods. It's really intimidating looking right now, but what you have to realize is that it kind of looks like a quadratic equation. You have something squared, you have a constant equals 0. So what we do in this kind of problem is called substitution to make the problem look simpler. I like to call this problem a quadratic in disguise. Same with the previous one. My name for these is quadratics in disguise. Now, how do I spell disguise? It's a G? Yeah, okay. Now I like that phrase because they are not quadratic, but they sure do act like quadratics. And sometimes I've seen books call them equations that you solve like quadratics, or equations that behave like quadratics, or something like that. So for number 5, this quadratic in disguise is going to be solved starting with a method called substitution. So you look at the middle term here, and you use a variable to represent that. So maybe I'll use a u. That's what your book commonly uses. You don't include any coefficient, just the variable part there. So let's let u equal x plus 1 to the 1/3 power. And once we do that, we realize that u squared is going to be x plus 1 to the 2/3 power. So then we can rewrite our equation as this part here is u squared minus this part here is u minus 2 equals 0. And this is a quadratic equation that we can solve. It happens to be factorable, so it factors into u minus 2 times u plus 1, and then we can use the zero product property and set each factor equal to 0. Solve each one. We get u equals 2 or u equals -1. But just be careful not to think you're done with that problem, because really Our goal for this problem is to solve for x, not to solve for u. So we need to keep going. So remember what u was. U was x plus 1 to the 1/3. So I'm going to substitute that back in. X plus 1 to the 1/3 power equals 2, or x plus 1 to the 1/3 power equals -1. Okay, so to solve each of these, we start by cubing both sides. Cubing will undo the 1/3 power. So that gives us x plus 1 is 2 cubed. 2 cubed is 8. And then subtract 1 from both sides, we get x equals 7. And then for the other one, cube both sides. X plus 1 equals -1 cubed. -1 cubed is -1. And then subtract 1 from both sides, x equals -2. Okay, so that's the substitution method for a quadratic in disguise. Here we have our assignment for today. So we have some problems from page 119 and some problems from page 144. Remember, the ones with hearts around them have tutorial videos available. So if you get stuck on any of those, please watch the tutorial videos and then submit your pictures of your notes, your pictures of your assignment, and make sure you show that you've checked your answers. Thank you.